Hey, welcome back to the Halite III series. Um, I actually don't quite remember where we left off. I think we just finished our training script and potentially be able to run it fully. I think I already debugged this a little bit and still haven't quite resolved the NumPy array saving issues, but I realized how off camera I start playing around trying to get everything work, and then when I ran it for a couple of iterations I also realized for some reason the model is not learning. And I remembered also before I started out this series, kind of what I was missing in other series is that people do too much off camera and just don't show how stuff works, like only show, oh, this is the result. And I told myself I don't want to do this. So how do I see it's not learning? If you look at this is already a little bit dumbed down example, but I load 4,000 training samples. Here I debug printed the output. You can see this is the 8x8 grid. Here's where the two bases are. The second feature is where the ships are. This is my ship, this is an enemy ship. The next one is how much the ship has loaded. Nothing, because it's the first turn. And this is where the drop-offs are. And the last one is which ship is currently to move. Okay, cool. Then if we look at this, we train for iterations, the loss is 1694, and now it seems maybe it's learning a little bit. So it really slowly decreases, which is a little bit funny for me, because before, when I ran my other code base, basically this one on a bigger field, it was just learning fine, even with the big network. So the first thing I did when I realized that the loss is actually not decreasing or it's oscillating or something, I increased the sample size a little bit to see if anything there, but maybe that's the wrong way to go about it. I remembered the easiest thing to do is just dump it down, make it easier. Like we have this convolutional layers and stuff. I just removed everything except for 2 dense layers. So now our network basically just has 2 dense layers. In my experience, usually they should be able to easily overfit the problem. One thing that's also interesting to me is that even though our loss is decreasing, our accuracy jumps a lot, between 70 and 30% or something, where you could say, okay, we're not necessarily optimizing for this, but the better our loss gets, the more accurate our prediction should be. Accurate in the sense that the actually predicted highest reward choice is the same as the one in the label. The loss is decreasing though, it's just very slow, so maybe I have to run it for more episodes. I mean, this is now almost running 100 episodes. Before this one, I tried running it with the learning rate increased by 10, multiplied by 10, I don't know, one less decimal after the comma. And you can see it's 50, 30, 30, 30, 28, 29, 36, here it's increasing again. So this was not learning at all. Now, since this one seems fine, it's maybe eventually converging to something. The next thing I would want to test is, okay, if this network is able to learn this, let's try to overfit it. Let's just feed it, I don't know, 10 samples. Can we learn 10 samples perfectly in 100 epochs? The loss is huge, and it's not really increasing. It's not really decreasing in loss, is it? It's decreasing a little bit. Okay, so it's learning something, but it's not overfitting this. Okay, let's see. We want to really make sure that we can overfit this. I don't know, let's learn a little bit faster too. This is just 10 samples. This is surprising to me. I think the network like this should be able to perfectly fit those 10 samples within a couple of epochs. Suddenly you see our accuracy somewhere in the 70s. This is strange. This is really strange. So I assume we have an issue somewhere in our training data generation. Because the network is not going to get any simpler, really. Let's check this. So actually here, I think I want to insert a couple of print statements. I want to print, let's make this an F string, and here we do input to wait for us. We want to see, yeah, the state doesn't help us much. Well, maybe. Let me think. I would definitely want to see the current queue. I want to see the future queue. I want to see the new queue. I want to see action index, reward. Oh. And let's also print it done. Let's just see if this is already helping in any way. Here we can actually, 20 games. Doesn't matter. It doesn't matter. Okay, what do we have here? Okay, this looks already like something is not correct. Let me see. We print current queue. Current queue. Oh, I see what's happening here. Maybe. Print current queue shape, future queue. So maybe we need to have another loop. So same as game 0 here is actually a list of all the features. 8, 5. This is already strange. 5, 5, 8, 5. What's in here? Current queue. Look at this. This seems so wrong. I should print game shape up and then input. So let's run this again. I guess there's some issue in how we load our training data. So our game consists of 4 lists, which, if we look into this one, we save an array which contains a list of states, actions, rewards, and dones. This one looks to be the dones. We have 1, 2, 3, 4, 5, 6 moves only, which is interesting. But given that we have 2 crashes, usually we have 8 moves, 9 moves. The first move, so the game runs for 10 turns. The first turn is no move because we have to build a ship, and then we have 9 moves to do. Minus 2 should be 7, but also the last one is missing because the game doesn't call us on the last frame. So we submit our last moves, but the game loop doesn't run anymore. Okay, 1, 4, 1, 1, 4, 1, 0. Seems to be all right. And then here we have all the frames stacked on top of each other, which is okay. So now our zip seems to destroy something. We take game 0, which should have a shape of 9, 5, 8, 8. Also, it's a list, actually. Yeah, this is a list of 9. 588. Okay. 588. This is one feature frame. So if we zip over this, then state should be a feature frame. Cool. And current queues. Model predict queues. Now current queue is shape. Let's see what the output of the prediction is. It should be 9588 shape. Or 7585, which is super interesting. Why is it 85? 7 is the number of samples we have. So these shapes should match. Game 0. Actually, feed. Let's see what happens here. Pooh. Why? So print current queues 0. What's in here? Now we take the first sample and we actually also print a shape of this one. Let's see what happens. Maybe it's super easy to see. I don't see it right now. Okay, one thing is probably we already trained this network to be quite broken because it predicts the same value for everything. 1, 2, 3, 4, 5, 6, 7, 8. So 5, 8, 5. 4, 5. Is this correct? Oh, yeah. We have. Let me think about it. Game 0 is the first state. If I predict this state, I expect the output to be 1 times 5. Instead it's 8 times 5. Let me just see what happens if we predict this. List index out of range. Print train. Ooh. We take the first frame in the game. No. List index out of range. Where is this? 146. How do you get here? Because this one fails. Oh god. I actually inserted this because some of our training samples were failing. So we do have 4 dimensions. Print feed shape. This will now be 588 and we need to reshape this to reshape to 1 feed shape. Okay. 585. 585. 185 feet. 588. What I don't understand is I expect this to be somehow different. So when we predict something in our network, we can actually feed. Let's do this. we input a state to our network, and I expect us to get back an array feed shape 588. And now we reshape this to one sample. Is this correct somehow? Let me see here. 5. Yo. And here we do the same. We generate this state and we reshape it to one state shape, and then we get the first current queues shape. So current queues shape is this. This is so strange. I want to play with this in IPython. And then where do I load my model? Model, and then we go for experiments, first try model. Okay, cool. Now we have the model, and then we say we just open any file. Experiments, first try, training 1.0, anything. Really, data equals. So data shape 4, this is the same. Data 0 shape. Also, this is now a list. Then this list has 8, one for each sample. And then shape, that's the shape of this first number 588. And we do model, predict, data 0, 0, reshape 0, shape like this. Oops. Reshape, data shape, bam. And then we get this strange output. Okay. Maybe I'm casting something wrong. D shape 588. D shape 1. It's not a function. Ooh. Yeah, let me see. Maybe this is not the shape I want. 1588. Yeah. 1, then 5, 8 by 8. The model predict in here. 585. This is so strange. What happens if I do an np argmax on this one? $63. Let's just see if I run this. Ah yeah, here I get index list out of range. Okay, let's see what happened here. Maybe I broke it somewhere else along the way, which would be weird. Then let's look at the git status in a second. Move index print current queue shape. Not print. Login info. Oh yeah, here we get the same garbage suddenly. Let's delete this model, let's delete this one, and then let's check our model specification. Because if I check the model summary, 585, here it is. Oh, oh, yeah, oh god. Okay, what happened? By making the model dumber, I feed in, what do I do? Output size, create model, output size, 5, create model. I think I do have to flatten the input, otherwise we take in this, the shape of the input. Oh, this is dumb. And it's stupid that it didn't fail. Now we get what we expect. Is this dumb? Okay, then that already concludes 20 minutes of searching. Let's now see if this model is able to learn anything. Oh no. Let's see if this works again. Okay. Oh. Checking. Somewhere I have this one I don't need. Okay, this is still kind of oscillating, so now we could try and see if maybe the learning rate impacts this somehow. Let's remove this stuff. Let's remove the model just to be sure. We start clean, 20 samples. Okay, my PC starts fanning up, but overall we see this loss is decreasing a bit faster than last time. Now if we just rerun it, we retrain on all this data. And one more time, just to see. Sorry, I think the sound quality is going down the drain when my PC is so loud. Yeah, you see now the network is able to perfectly overfit this data. Okay, this is good. I mean, you can run it a couple more times. One thing which should probably throw us off a bit is that the accuracy can change so drastically, but I think this doesn't matter because we only had 10 samples, right? So if you, or 20 or what, if you get one wrong, then immediately you're only at 80, 90% accuracy. Now bear with me, we're gonna load the full 5,000 samples that I generated so far. Again, you could say, okay, with the Q-learning algorithm, we were able to learn something meaningful within 1,000 samples. I think once we set this up, correctly, we can learn a lot with less samples. This is interesting. I get a couple of errors when loading files. So there's some with broken CRC, and there's some where the shape of something doesn't match. Overall, I found that when I store all of these in a NumPy array, and obviously what I'm doing is like hacking it together somehow, because the states, the shape of this array is very different from the action indices or the rewards, but internally NumPy just tries to make a n-dimensional array, which encompasses all of them, I guess. So yeah, this is a bit awkward, especially if they don't have the same number of samples. Sometimes we have less rewards or actions than we have states. That's probably where this comes from. This takes a little bit. Maybe it would have been fine if I loaded half the data. There's surprisingly many broken games. Maybe I ran a couple iterations with some broken version. Oh god. In the end, I'm going to delete this and run it again to make sure it's clean. And I'm going to delete all of these samples as well. I mean, live and learn. 535. Almost there. This can go. This can go. So now I feel I want to keep these closer together, because every time I scroll to either one of them to search for the other, and these should probably all be on top, whatever. Almost there. There's the print somewhere. This one can go. Okay, do we learn anything? Oh, I should have probably not ran this for 1,000 epochs. But this looks like I hoped it would. So the loss is decreasing, the accuracy is more or less increasing. Let's see. I think in the final loop that I planned on doing, I would run it for 5 to 10 epochs, and then run the next game. Interesting. So I guess in the next step I will start putting the convolutions back and see if I'm still learning. And then, because the video gets annoying when you hear the fanning of my laptop, I will run this offline for a couple of episodes just to see if something's happening, and then we can see if the bot is actually doing something. And once we figure this out, we will actually finally make the next step. Yeah, overall this looks good. I mean, loss is decreasing like you would expect it to. It's a bit slow in decreasing, so I wonder if we can increase the learning rate. But yeah, this is overall okay. So I think I will maybe run a last 3 here. Okay. It's a pretty beefy network. Dense output. Okay, I think this is fine. Let's delete this model. Okay, this is how I'm gonna run it now to see if it trains. If this is doing, I'm gonna restart it with a couple less episodes and lower epsilon decrease. Okay. See you in the next episode, hopefully with some learning going on.